Figures are figures that are the exact same shape and size. Please write that in. Congruent figures are the exact same shape and the exact same size. When two figures are congruent, all of their corresponding parts are also congruent. And we call this the CPCF theorem, which stands for corresponding parts of congruent figures. CPCF. Write a triangle congruent statement. You have to put corresponding parts in the same place. So if I choose triangle ABC and I name it in that order, ABC, I'm going to say it's congruent to triangle, and I have to go in the same order. So A corresponds to Y. They'd be the same angle measure. Y must come first. What letter does B correspond to? B corresponds to X. They're both 90-degree angles, so X must come next. And then C would correspond to Z, so Z must come last because C came last. These congruent triangles, I'm going to say triangle, and I'm going to say MAP because it looks like map, and that's kind of that's funny. That's hilarious. Triangle MAP is congruent to, again, equal sign with toothpaste over it. M is between the side that has one marking and three markings. So over here, that would be U. So U has to come first. Okay? A, my next letter, is between the 1 and the 2 markings. So over here, that would be N. N would come next. And then I know R must come last because it's the only letter left. So I'm going to do the angle pairs first. Angle P must be congruent to angle S because they're both first. All right? Angle Q must be congruent to angle T because they both come second. Angle R must be congruent to angle W because they both come last. Okay, so you've got 3 pairs of corresponding angles. Then you've got to do pairs of corresponding sides. All right, now I'm going to draw these so you guys can see them. You can draw any generic triangle, P, Q, R, and then you just draw another triangle next to it, but it's got to go in the same order. So PQR, STW. See how I went left, up, down? Same thing. Now you can just look at the side lengths. PQ is congruent to ST, so I write it. PQ is congruent to ST.
Don't you have to have the arrows for
Other congruent sides, I've got PR is congruent to SW. PR is congruent to SW, and I write it and I put a segment over each one. And then the last one, obviously, is the one that's not marked. It'd be QR is congruent to TW, and I put a segment over it, and I can mark those. I can mark those with 3 lines. Now I want you guys to notice something when I was doing the segments. Notice how I said PQ equals ST? Okay, look where PQ, first 2 letters, and ST is. First 2 letters. Okay? And then I said PR is congruent to SW. Well, PR is the first and last letter. Guess what SW is? First and last letter. And then I said QR, the last 2 letters, is congruent to TW. Guess what? Last 2 letters. So you don't even really need to draw the figures. I did it. You can do it. You don't actually need to. All you need to look at is the order in the congruency statement, and you can come up with all that stuff. Cap. Segment AB is equal to segment DE because they're the first 2 letters, they're the first 2 letters. AB equals DE. So therefore, I can say, hey, 2x minus 2 equals 6. And I realize there's a whole lot of information other than that given here. You've got angle measures, you've got that being the length of 10. None of that matters to solve for x. We know 2x minus 2 equals 6, which we have right here. And to solve for x, we add 2, we get 2x equals 8, and then we divide by 2, and x equals 4. And we're done. Okay?